Have you ever looked at animals and wondered what truly drives them? Especially, when it comes to finding a mate.
Yeah.
It's way more complex and honestly fascinating than you might first think.
Absolutely.
Welcome to the Deep Dive. Today we're diving deep into the, well, surprisingly distinct breeding behaviors of two groups that seem pretty similar on the surface. Camelidae, that's camels, llamas, alpacas, and Cervidae, which is all the deer species.
And we've got some really interesting material for you. Sources looking at camelid and cervid breeding behavior, and another exploring what we're calling ovulations echo, focusing on these behavioral syndromes.
Right, and these don't just tell us what they do, but really get into the why, right? Going way back to their evolution.
See, exactly. Down to their ancient paths.
So our mission today is to unpack the core physiological differences shaping their reproductive lives. We'll explore their unique courtships and, crucially, how human interaction can sometimes mess things up, dangerously so.
Yeah, get ready for some aha moments, because this is where it gets really interesting.
Okay, so you mentioned these two groups seem similar, but there's this fundamental critical difference dictating their breeding. What is that linchpin?
It really all boils down to one thing: their mechanism of ovulation. It's the key.
Ovulation? How so?
Well, camelids are what we call induced ovulators.
Induced meaning?
Meaning the physical act of mating itself is what triggers the female to ovulate, usually about, 24 to 30 hours later.
Wow.
And this allows for almost constant follicular activity, the egg development, and extended receptivity. It frees them from strict seasonality.
So wait, induced ovulation means they're basically ready to go, potentially year-round, not tied to seasons.
Pretty much, yeah. It totally changes the game for them.
Okay, so how different is that from the deer, the cervids?
Oh, completely different. Cervids are spontaneous ovulators.
Spontaneous.
Yeah, their cycle is like an internal clock. It's endogenous, and it's synchronized mostly by environmental cues, especially changing daylight length, the photoperiod.
Ah, the amount of light in a day.
Yeah, exactly. So female receptivity, estrus, it's very brief, highly seasonal, and that creates this compressed, really high-stakes mating period, the rut.
The rut, right, okay. And these differences, they're not recent adaptations, are they? You said they go way back.
Way, way back. Deep evolutionary roots. Their paths split incredibly early. Maybe early Eocene epoch? We're talking 40, 50 million years ago.
50 million years.
Yeah.
So these aren't just minor tweaks.
No, not at all. These are fundamental biological blueprints set tens of millions of years ago. It influences everything: their stomachs, how they walk, even their blood cells.
Like what? Give me an example.
Okay, so camelids are tylopoda padded foot. They have a 3-compartment stomach, resistant to bloat, unique elliptical red blood cells, different placenta type, and male camelids have this distinctive corkscrew-like penis tip. It's cartilaginous.
Huh, okay. And cervids?
They're ruminantia, true ruminants. Cloven hooves, 4-compartment stomach, more prone to bloat, different placenta, again, cotyledonary. And of course, they usually grow antlers.
So it's this whole package of deeply embedded differences.
Way
beyond just ovulation. And I guess these differences then dictate their mating systems.
Precisely. For camelids, that induced ovulation, it favors something called resource defense polygyny.
Resource defense polygyny. Break that down.
Basically, males defend a territory with good resources. Food, water. This gives them stable, long-term access to the females living there, allows for opportunistic mating, more or less year-round.
And that leads to those stable family groups you mentioned.
And batch
Like
size.
herds.
Exactly. Very stable social structures.
Whereas the cervids, with their synchronized short estrus, that sounds way more dramatic.
It is. It creates this intense, almost winner-take-all market during the rut. Huge pressure.
And that's what drives the evolution of things like the big antlers. And the bugling.
Absolutely. Those are costly signals. Think huge antlers, exhausting fights, loud vocal displays like the elk bugle. It's all about showing off fitness. And it forces females to have efficient ways to choose the best male quickly, like making excursions or visiting leks.
Okay, that framework makes sense. So let's zoom in on the camelids now. Resource defense, polygyny, stable groups. Is it all peaceful? Or is there still competition?
Oh, there's definitely still competition in dominance hierarchies. You'll see spitting, maybe some body charging to establish rank.
Spitting llamas, classic.
Yeah, but generally it's less overt, less intense conflict compared to the cervid rut. It's more about maintaining order within that stable group.
Got it. And the courtship itself.
Yep.
You mentioned the cush and the orgle. What's going on there?
Okay, so the male pursues a female. If she's receptive, she'll signal by adopting the crisp position. Basically, she lies down on her sternum.
Dush, okay.
And then the mating itself, it's incredibly long. It can be anywhere from like 5 minutes up to nearly an hour. Typically, though, maybe 15, 25 minutes.
That's a long time compared to many animals.
It is. And throughout this whole time, the male makes this continuous guttural sound that's the orgling.
Orgle.
Oh,
Okay.
yeah.
And the mechanics are specialized, too, with that unique penis you mentioned.
Yeah. Yes, exactly. That corkscrew tip isn't just for show. It physically dilates the female's cervix so he can inseminate directly into the uterus. Bypasses the vagina altogether.
Direct uterine insemination.
Wow.
And the semen delivery is different, too.
Yeah, it's not one big ejaculation. It's delivered in these sort of pulsatile dribbles throughout that whole long mating period.
Like, this is incredibly intricate. It sounds almost, well, bizarre out of context. But there has to be a biological reason for all this, right? The long duration, the orgling, the dribbles, the special anatomy. What's the why?
It all comes together, this whole suite of behaviors, the duration, the sound, the direct uterine insemination, the dribble delivery. It's a co-evolved system. It's all designed to ensure one critical thing happens.
It is.
The effective delivery and absorption of something called the ovulation-inducing factor, or OIF, which is in the semen.
OIF, okay.
We now know this factor is actually a protein beta nerve growth factor, BETA-NGF. The whole elaborate process ensures enough of this chemical signal gets absorbed into the female's bloodstream.
To trigger what?
To trigger the hormonal cascade, specifically the luteinizing hormone surge, or LH surge, that finally causes ovulation about a day later.
Ah, okay. So the long mating, the orgling, the special delivery, it's all to make absolutely sure that ovulation-inducing chemical signal gets through.
Precisely. Every strange piece fits. It's perfectly adapted to ensure that induced ovulation happens reliably. That's the elegance of their system.
And the female's body complements this. You said no defined estrus cycle.
Correct. Instead, they have these continuous overlapping waves of follicular development. Happens roughly every, say, 12 to 21 days. She's only receptive when a follicle is actually growing and reaches a minimum size, about 7 millimeter.
Fascinating. And then if mating is successful and she ovulates and conceives, you get this natural pregnancy test, the spit-off.
Yep. It's a great indicator for breeders, actually.
How does it work?
After successful ovulation and conception, the corpus luteum forms and starts producing progesterone. That progesterone makes the female non-receptive to further mating.
So if a male tries again,
She'll aggressively reject him. Spitting, refusing to go into the cush position, running away, it's a pretty clear signal. Nope, already pregnant.
that's quite definitive.
Okay.
And then gestation and birth. Long gestation, you said.
Yeah, relatively long. About 335 days for alpacas, maybe 350 for llamas.
But the timing of the birth itself is remarkable.
It really is. Over 90% of births happen during daylight hours, usually between 7 a.m. and 3 p.m.
Why so specific?
It's a clear adaptation, likely from their origins in the high Andes. It gives the newborn cria, the baby, enough time to dry off before the cold mountain nights set in. And birth usually happens standing up.
And the cria themselves are unique, born with a membrane.
Yeah, they're born covered in this thin, sort of semi-transparent epidermal membrane. It's unique to camelids. And interestingly, the mother, the dam, doesn't lick the cria clean or eat the placenta like many other mammals, including deer.
But the cria is up and about quickly.
Very quickly. They're highly precocial, standing and nursing usually within the first hour. They need to be mobile fast to follow mom. It's a follower strategy.
Follower strategy. Okay, let's contrast that with the cervids, the deer family. You called their breeding season the high-stakes theater of the rut. Sounds intense.
It absolutely is. That timing, the rut, it's critical for offspring survival.
And it's triggered by
Decreasing daylight. That shorter photoperiod in late summer, early autumn, kicks off a whole hormonal cascade, melatonin, prolactin, LH, testosterone in the males.
and the purpose of that autumn timing.
It ensures births happen in the spring or early summer. That lines up perfectly with peak vegetation growth, which is crucial for the nursing mothers, and later for the weaned young. This is especially pronounced in northern climates, maybe a bit more drawn out further south.
Makes sense. And during the rut, the male competition is fierce. You called it a war of information and endurance. Antlers aren't just decorations then.
Definitely not. They're primary weapons and status symbols. You see sparring early on, lower intensity, pushing and shoving. That helps establish hierarchies, maybe even social bonds.
But then it gets serious.
Oh yeah. Between evenly matched rivals, you get real fighting, sometimes called the antler rush. It's serious, violent, often preceded by these ritualized displays like dropping the ears, the hard looks, sidling up to each other.
And they fight with sound and smell, too.
Absolutely. Think of the elk bugle. That's acoustic warfare. This is a powerful, complex sound advertising the bull's presence, his condition, attracting females, warning off rivals, holding his harem together.
Smell.
Scent marking is huge. Males make rubs by rubbing their antlers and foreheads on trees, leaving scent from glands. And they make scrapes, pawing the ground, urinating in it. Both broadcast the male's presence, his dominance, his physiological state. It's olfactory warfare.
So putting all that energy into antlers, fighting, bugling, marking,
Yeah.
it must be incredibly draining.
Hugely draining. They often lose a lot of weight during the rut. This ties directly into what biologists call costly signaling theory, meaning these displays are such enormous energetic investments, growing huge antlers, risking injury in fights, not eating much, that they serve as honest signals of genetic quality. Only the fittest males can afford such costly displays. They're hard to fake.
And the females are paying close attention to these signals. They're not just passive bystanders during their short receptive window.
Not at all. Females are active participants. They have to be efficient assessors, given the short time frame.
What kind of strategies do they use, like white-tailed deer?
White-tailed might use different tactics depending on the situation. In high-density areas, maybe a sit-and-wait strategy, moving less within a small core area, conserving energy, letting bucks find them, or they might use excursive behavior, taking these short trips outside their usual home range. This advertises their receptivity more widely, potentially attracting more males and inciting competition between them, which helps the female assess quality.
And some deer species use lecking, like fallow deer.
Right. Lecking is fascinating. Males gather in these traditional display areas called leks. Each male defends a tiny territory within the lek. Females come to the lek specifically to shop around, comparing multiple males simultaneously.
And they usually prefer.
Often the dominant males holding the central territories within the lek. It's a very efficient comparison market for the females.
Okay, so after all that drama, mating happens. Gestation is shorter than camelids.
Yeah, significantly shorter, around 200 days for white-tailed deer, maybe 250 for elk.
And then fawning. You said this is the opposite of the camelid follower strategy. This is a hider strategy.
Exactly. The female seeks out a secluded spot to give birth, and the newborn fawn. It relies on camouflage and stillness. It stays motionless, hidden in dense vegetation for weeks.
How does it survive hidden like that?
Its spotted coat provides camouflage, and crucially, young fawns have very little scent, making them hard for predators to find. The mother actually stays away most of the time, only returning for brief periods to nurse. It's a vital anti-predator tactic.
Wow, quite different from the cria needing to follow mom immediately. And I bet those mothers are fiercely protective of their hidden fawns.
Incredibly protective. A doe will aggressively defend her hidden fawn against anything she perceives as a threat.
Okay, now here's where things get complicated and, frankly, sad. When the human world collides with these instincts, both groups seem vulnerable to issues related to imprinting and habituation. Can you define those quickly?
Sure. Imprinting is this really rapid, often irreversible learning process right after birth. It's crucial for recognizing their own species, forming social bonds, and knowing who to mate with later.
And mal-imprinting.
That's when imprinting goes wrong. The animal imprints on humans instead of its own kind, usually due to being isolated and having intensive human contact, like, say, bottle feeding an orphan without careful management.
And habituation is different.
Yeah, habituation is more gradual. It's the loss of the natural fear response towards humans, often because of repeated exposure, especially feeding. Both can lead to really dangerous situations down the line.
Let's tackle the camelid side first. Aberrant behavior syndrome, ABS, sometimes called berserk male syndrome or BMS. This isn't technically a medical condition, is it?
No, that's key. It's a behavioral disorder, and importantly, it's preventable. It results from that mal-imprinting we just talked about. The animal fundamentally sees humans as members of its own species, as rivals or potential mates.
And what causes it? How does it happen?
It's caused by too much inappropriate human socialization during that critical imprinting window, birth up to maybe 6 months, often compounded by being separated from the dam and the herd. Things like treating it like a pet, constant handling, cuddling. Bottle feeding is often involved, but it's the vehicle for the excessive improper contact, not the direct cause itself.
And the early signs are often missed or even encouraged.
Exactly. When they're young, these creases seem super tame or friendly. They don't show fear. They get right in your personal space, follow you around, nibble clothes, nudge you for petting. People think it's cute.
But it's not.
It's actually them practicing normal camelid social behaviors, boundary testing on the humans they perceive as herd mates.
And then they grow up.
Right. And as they hit social and sexual maturity, usually between 1 and 3 years old, those seemingly benign behaviors escalate into serious aggression.
How so?
The animal starts directing its normal species-typical dominance, territorial, and even reproductive behaviors towards humans. Things like charging, chest ramming, serious biting, spitting aggressively, trying to leg wrestle or knock people down. Males might even make those orgling sounds towards humans.
That sounds incredibly dangerous. An adult llama or alpaca can do real harm.
Absolutely. And while it's often most pronounced in dangerous and intact males, hence berserk male syndrome, it can definitely happen in gelded males and females too. Females might become extremely aggressive spitters or just completely unmanageable.
So once this mature aggression starts,
Yeah.
what's the prognosis? Can it be fixed?
Honestly, it's extremely poor, very, very difficult, bordering on impossible to fix once established.
Why is that?
Because it's not just bad habits. It's rooted in that deep-seated malimprinting during a critical developmental window. Trying things like behavioral modification, castration after the aggression starts, isolation, they rarely work reliably.
So the outcome is often.
Sadly, because of the severe and unpredictable danger these animals pose to humans, euthanasia is frequently the most responsible and sometimes the only option.
That's really tragic, which means prevention is absolutely everything.
It's the only effective strategy. Crias must be raised by their mothers within the herd environment. If bottle feeding is absolutely unavoidable for survival, human contact needs to be kept to the bare minimum. Think hands-free feeding setups, returning the cria immediately to the herd afterwards. Never, ever treat them like pets. Encourage cuddling or constant handling.
And there's a catch-22 with castration too, isn't there?
Yeah. There is. Castrating males early, before maturity, might reduce the risk of severe ABS developing. But castrating them too young, like before 18-24 months, interferes with the closure of bone growth plates. This can lead to serious musculoskeletal problems later in life, overly long legs, joint issues like luxating patellas, arthritis, so it's a difficult trade-off.
A really tough situation. Okay, now let's switch to the cervids, the deer. We see a parallel problem with tame aggression impacting public safety. How does this typically arise in deer?
It usually comes from one of two things. Either someone illegally hand-rears a fawn they thought was orphaned, often mistakenly kidnapped, from its hiding mother, or, more commonly, it's from people repeatedly feeding wild deer.
And the result is the same loss of fear.
Exactly. The deer learns to associate humans with food and loses its natural healthy fear. Its innate flight response erodes.
And just like with the camelids, this loss of fear creates danger, doesn't it?
Absolutely. A habituated deer isn't a pet, it's a wild animal that's lost its fear, which makes it unpredictable and dangerous.
Especially during certain times.
Definitely. The rut is probably the most dangerous period. A tame buck, juiced up on testosterone, doesn't see humans or even pets or cars as things to avoid anymore. He might see them as rivals.
And attack.
Yes. Directing full aggressive behaviors, charging, goring with those sharp antlers, striking and trampling with powerful hooves. These attacks can be, and sometimes are, fatal to people.
And it's not just the bucks during the rut.
No. A habituated doe, because she's lost her fear, won't necessarily flee if you approach her hidden fawn. Instead, she might stand her ground and aggressively attack people or pets she perceives as threats to her young.
Also, injured or cornered deer.
Right. A sick, injured, or cornered deer that's habituated is more likely to fight back rather than try to escape because that fear threshold is gone.
So managing this becomes a serious public safety challenge.
It really does. And unlike the ABS camelid, which is usually a private owner issue, this often involves wildlife agencies dealing with animals in public spaces.
Can these habituated aggressive deer be rehabilitated or moved?
Generally, no. It's usually not considered a viable option. They pose too much risk. Often, unfortunately, they have to be euthanized for public safety.
So again, prevention is key.
It is. Public education is paramount. Campaigns emphasizing the dangers of feeding wildlife. You often hear the phrase, a fed deer is a dead deer, and there's truth to that in this context. And in places where you have large populations of overabundant, habituated deer causing problems, population control measures like managed hunts or agency culling might become necessary.
Okay, so we have these two parallel problems stemming from disrupted natural behavior due to human interference. But help us connect the dots for the listener. What's the core difference in the type of danger posed by an ABS camelid versus a tame, aggressive deer?
That's a great question, and it's crucial to understand. The danger comes from different places, psychologically speaking, for the animal. The ABS camelid, because it's malimprinted, literally sees you, the human, as another camelid, a conspecific. So the aggression it directs at you is social aggression. It's engaging in a dominant struggle, using its normal species behavior, spitting, biting, chest ramming, to establish rank, just like it would with another llama or alpaca.
So it's a social conflict misdirected, and it could happen anytime.
Exactly. Rooted in social dynamics can manifest year-round whenever that perceived social challenge occurs.
Whereas the tame, aggressive cervid.
The habituated deer hasn't necessarily malimprinted. It hasn't recategorized you as deer. It's just recategorized you from potential predator threat to neutral or maybe food source. The fear is gone.
Yeah.
So the danger arises when its powerful hormonal drives kick in, things like the testosterone surge during the rut or the intense maternal protectiveness. When those triggers are pulled, the deer acts on them. But because you're no longer perceived as something to flee from, you might become the target of that hormonally driven aggression, territorial defense, rival elimination, maternal defense.
Using its weapons, antlers, and hooves.
Right. So the danger from the habituated deer is primarily hormonal and often seasonal, rut, fawning season. The tragedy in both cases is the same, though. The animal is behaving normally according to its species programming. It's just that the behavior is dangerously misdirected at humans because of our interference.
That distinction is really helpful, and it highlights how both syndromes are fundamentally failures of animal welfare caused by us. These animals are stuck, aren't they?
They really are, in a kind of psychological no man's land. They can't interact properly with their own kind, and they can't interact safely with humans. That state of chronic dysfunction, combined with the high likelihood of euthanasia, represents significant suffering.
Yeah, and there's still a lot we don't know, right? Gaps in knowledge.
Definitely. We need more research into the actual neurobiology of malimprinting. What changes in the brain? Why is it so hard to reverse?
And interventions.
We need controlled studies on whether behavioral interventions can work, especially if caught very early. And are there genetic factors? Maybe certain lines of domestic camelids are more predisposed?
And that ovulation-inducing factor, the OIF, NGF, that sounds like it has wider implications, too.
Potentially huge implications. Finding this protein driving ovulation in camelids, but realizing it's also present in the semen of many spontaneous ovulators, including humans, suggests it might play other, currently unknown roles in reproduction across mammals. That's a really exciting area for future research.
You know, thinking about how we manage these two problems really highlights something interesting about society, doesn't it?
How so?
Well, for the ABS camelid, it's usually a privately owned domestic animal. And the solution is framed as individual owner responsibility, right? Micro level. Don't overhandle your carrier. Manage your own animal.
Right. It falls on the owner.
But for the tame, aggressive deer, which is considered public trust wildlife, the solution becomes macro level, government agency responsibility. We need feeding bans, we need managed hunts, public safety campaigns.
That's a really sharp observation. The response framework is totally different.
And that difference seems driven almost entirely by the animal's legal status, domestic pet versus public wildlife, rather than the shared biological root of the problem, which is human interference disrupting innate behavior. It's kind of a profound reflection of how our legal and societal structures shape how we even approach human-animal conflict, isn't it? What stands out to you about that divergence?
That's a powerful point to ponder. It really makes you think about those classifications.
Wow. We've covered a lot of ground today, a true deep dive from ancient evolutionary splits and ovulation mechanisms all the way to these complex human-caused behavioral issues.
It really shows how interconnected everything is: physiology, behavior, evolution, and unfortunately, the impact of human choices.
So the next time you see a llama calmly chewing or a deer stepping out of the woods, maybe pause and consider that incredibly complex biological programming running its life, and how our actions, Even well-intentioned ones like feeding can fundamentally alter its path, sometimes with tragic consequences.
It makes you wonder, doesn't it? What other animal behaviors that seem simple on the surface have these incredibly deep, complex, and surprising biological roots we haven't even uncovered yet?
Absolutely. Well, thank you for joining us on this deep dive. We hope this gave you some surprising facts, maybe a shortcut to being better informed, and some new insights to carry with you.
We'll be back soon with another deep dive just for you.